In today's fast-paced technological landscape, building applications that are both performant and scalable is paramount. Traditional monolithic architectures often struggle to keep up with these demands. This is where Command Query Responsibility Segregation, or CQRS, comes in. CQRS is a powerful architectural pattern that offers a fresh perspective on handling data. It separates actions that modify data, known as commands, from actions that retrieve data, known as queries. This separation enhances performance, scalability, and maintainability. To grasp the essence of CQRS, it is crucial to understand the fundamental concepts of commands and queries. Commands represent actions that change the state of our application. They are imperative in nature, instructing the system to perform a specific action. For instance, create user or place order are examples of commands. They are typically asynchronous and do not return any immediate data, acknowledging only the successful initiation of the requested action. Queries, on the other hand, are about retrieving data from the application. They are declarative in nature, expressing what data we want without specifying how to retrieve it. Examples of queries include GetUserBuy or GetOrdersByCustomer. Queries are synchronous, returning the requested data directly to the caller. This clear distinction between commands and queries is at the heart of CQRS. By separating them, we can treat them as distinct concerns, optimizing each path independently for maximum efficiency. Separating commands from queries brings numerous benefits, enhancing performance, scalability, and maintainability. Performance gains are a significant advantage of CQRS. By segregating reads and writes, we can optimize each path. Queries can be routed to an optimized read model using denormalized data structures and caching for fast retrieval. Scalability is another area where CQRS shines. We can scale reads and writes independently. Maintainability also gets a boost with CQRS. By separating concerns, we create a more modular codebase. Changes to the read model don't impact the write model, and vice versa. Section 4. CQRS Architecture. The architecture of a CQRS-based system revolves around the separation of commands and queries, with dedicated components handling each aspect. Commands are handled by command handlers, which encapsulate the logic for processing a specific command. When a command is received, it is dispatched to the appropriate command handler, which validates the command, applies business logic, and persists the changes to the right database. Queries, on the other hand, are handled by query handlers, which are responsible for retrieving data from the read database and returning it to the caller. Query handlers can leverage optimized data models and caching mechanisms to ensure fast and efficient data retrieval. The read and write databases can be the same database, or they can be different databases optimized for their respective tasks. In some cases, the read database might be a denormalized replica of the write database, optimized for fast read operations.
Let's look at a basic code example. Here's a command handler for creating a user and a query handler for retrieving user details. In this command handler, we're creating a new user. The command might be something like CreateUserCommand, which is processed by the command handler to update the user database. And here's a query handler that retrieves user details. This handler might use a different data store or a cached read model optimized for quick lookups. While CQRS offers many advantages, it comes with challenges. Increased complexity. Managing separate models for reads and writes can be complex. Data synchronization. Ensuring the read and write models are synchronized can be tricky. To wrap up, CQRS can be a powerful tool for managing complex systems and optimizing performance. If you're dealing with scalable applications or complex business logic, CQRS might be worth exploring. If you enjoyed this video, make sure to like, subscribe, and hit the bell icon. Leave your questions or comments below, and I'll see you in the next video.